Class 10 Science. I am R.S. Prasad sir. Today our chapter is 13 and that is the light reflection and refraction at spherical surfaces. चलिए देखते हैं. So this is your spherical ball and the two mirrors are cutting here and polished outside and inside. यहाँ पे आपका स्पेरिकल बॉल लिया हुआ है और बॉल से दो मिरर्स बनाए गए हैं. वन में तो इनसाइड पॉलिश की गई है और एक में आउटसाइड पॉलिश की गई है. तो जहां पर एक्सटर्नल सरफेस में पॉलिश है दैट इज द कॉन्वेक्स मिरर. इट इज योर कॉन्वेक्स मिरर एंड it is not convex, it is concave mirror. So you can say it is concave mirror. If it is inside the polish, so that is the convex mirror. Convex mirror. So you can see here polish is inside and here is outside polish. So that is the concave mirror. It is written here. And that one is the convex mirror. So you can watch this one and this one. So our topic is this mirror, spherical mirror. Now you can see here जिस imaginary sphere से ये कटे हैं उसी को हम center को center of curvature, that is the center of curvature, and this is the part of the mirror and the middle part of this one, that is called as pole. So that definition is circumference and center of curvature. It is a hollow cylinder, hollow glass spherical, and it is the main axis, that is the x and y. It is the main axis. So you can see here, and similarly in this mirror also, that is the center of curvature here. It is your center of curvature. It is the hollow glass sphere, and that is the main axis. This is the x and y, and here center of curvature, and that one is the point is 4. So these are the definition and you can write. Now come to the concave mirror. What will be? So all the parallel lines, these parallel rays after reflection they will meet at the focus. And here you can see it seems to be meet at focus. So this is the diagram. Now come to this one. It is a figure in which now come to the sign convention for the reflection at spherical surface. What is the sign? How can taking the sign? So that is the mirror. So left hand side of the mirror, that distance is always negative, and the right hand side distance all are positive. And here is the downwards of the axis, that is the negative, and upward from the axis, that is the positive. You can see here positive and negative. And behind the mirror, that is the positive. So you can see in this also it is the lens is concave mirror. This one is the concave mirror and that one is the convex mirror. In this also the right hand side of the mirror, that is the positive direction, and the left hand side of the mirror, that is the negative direction, and the downwards of the axis, that is the negative, and upward of the axis, that is the positive. You can see here. So this is the sign convention for the reflection of spherical surface. Let us see what is the laws of image formation for spherical mirrors. So first law you can see here. So converge at the focal point before traveling away from there. In the case of concave mirror, it is the case of concave mirror, and the second one appear to be coming from focal point in the case of convex mirror. You can see this is ये ray of incident है, देख लो यहाँ पे ये ray of incident है. ये after reflection कहाँ से पास होगी? It will be passes through focus. ये focus से पास होती हुई दिखेगा. और यहाँ पर क्या है? When it is parallel to principal axis, then after reflection it will seems to be coming from focus. So that is the focus, and you can see here it is the focus. Now it is that lens is that mirror is concave mirror and it is your convex mirror. Now come to the second law. The light ray which First step, passes through the focus of concave mirror, travel parallel to the principal axis, just opposite of the first rule, or appear to travel toward the focus of a convex mirror, travel parallel to the principal axis after reflection. You can see here. So that is the rays which is passing coming from focus. You can see coming from focus, and after reflection it will be parallel to the principal axis. As you know, it is the principal axis. Principal axis. So this is also principal axis. So you can see that this is the focus. It is seems to be coming from focus. So after reflection, it will be parallel to the principal axis. So that one is the principal axis. Principal axis. So that one is the concave mirror and it is convex. That is the convex mirror and it is the concave mirror. Now come to the third law. You can see here third law. We know that the light's rays incident normally on the mirror retrace their path after reflection. Therefore, first, light rays traveling through the center of curvature C retrace their path after reflection in the case of concave mirror. Now, in case of convex, light rays that appear to be directed toward the center of the curvature C for a convex mirror. So, retrace their path. So, you can see here in this here that is the concave mirror. In this is the rays which is coming here, and after reflection it will be going back. So it is going back and it is coming, and here is it seems to be coming from the center of curvature. So like, and after reflection it will be come back to that part. So that is the pole, and it is for convex mirror and it is for concave. Now come to the next fourth law. When the ray of light is incident on the pole making some angle with the principal axis, then after reflection it makes the same angle with the principal axis in the opposite y axis side. This is because the principal axis is normal to the mirror at the pole P, and that is the law of reflection. So it is these angles are equal. So that is I and it is the angle R, and the angle of incident is called as angle of incident, and that one is called as angle of reflection. You can see here in convex mirror and also in concave mirror. So you can say that is the angle of incidence, that one the I, and it is the angle of reflection, that is the R. So you can see in both the mirrors. So it is the same. Now come to the ray diagram for concave mirror. It is the ray diagram for concave. Object is placed at infinity. So it is placed at infinity. So then the image form at focus. So you can write here the image formed at focus. At focus. So that is the rear inverted highly diminished. It can be obtained on screen. So you can see here when the object is placed at the center of curvature. So that is the object. You can see that one is the object and it is your image. So in this, the image is equal to the size of object. That means they have the same size. Inverted, real, and in front of mirror. It can be obtained on screen. Now come to the second, when it is placed behind the object. Now it is the object C. So C से पीछे रख रहे हैं, that is the object. So you can see here that one is the object. And when ray is parallel, it is coming first parallel, this one, and after reflection it will be passes through focus, this one, and when it is passing through the center of curvature, so after reflection it will be come back to their origin point. So they intersect here, so it forms a image. Forms an image. So that object you can say AB, and the image is that is called as A dash B dash. So it is the image is real, inverted, small size, it can be obtained on the screen. Now in this also it is the object, you can see here, and when the object is between focus and the center of curvature, you can see here that is the center of curvature and focus. So object is placed here AB, and image is formed here A dash B dash, and that is the large image. You can say large, real, inverted, and same side of object. It can be obtained. It can be obtained on the screen. Now you can see when the object is placed at focus, so it is going at infinitive. So the reflection on the infinitive. When object is placed on focus, so the image is formed real, inverted, and highly magnified. Highly magnified. It can be obtained on the screen. Now it is a virtual image, so you can draw that is a dotted lines. The object is placed between focus and pole P. So you can see here when the object is between focus and the pole, so the image is formed virtual. How can virtual? When ray is coming at pole, so it is reflected at this same angle, so it is looking like, and when the rays is coming from center of curvature, so it will be come back its original path. So they can meet at behind the, it seems to be meet behind the mirror, and the image is formed A dash B dash. So the image is formed virtual, erect, it cannot be obtained on this. इसे पर्दे पर नहीं ले सकते हैं, और ये seems to be behind the mirror. Now come to the next one, that is the image formation by the convex mirrors. It is a convex mirror. You can see here convex mirror. So there is only one possibility or two possibilities you can see. When the objects are placed at infinitive, so that is the infinitive. So the image form at focus, it's a very diminished, and the image formed virtual, highly diminished, and here when that is when at a definite distance from the mirror. So that one is the convex mirror. यहाँ पर जो है ये फोकस एंड सेंटर ऑफ कर्वेचर के मिड में बनेगा इमेज. So the image is formed virtual, direct, and small size. It cannot be obtained on scale. So you can write this one. So relation between the focal length f and the radius of curvature capital R. So you can see here the ray diagram. Suppose it is the P. For this P here, you can say it is the. You can say the point is it is the incident ray. You can say here AB, and after reflection it will be passed through the focus. Now we can take by the angle of this one ABC. Angle of ABC is equal to angle of FCB by law of reflection. Now the angle is FBC. You can see here R. It is represented by R. So that one is the I and it is your R. So now by alternate interior angle, which angle is equal to? So angle of BCF is equal to angle of ABC. So this equation is first and that is the second. So by equation first and second, both the angles are equal. So you can say here FCB is equal to angle of CBF. So it is a isosceles angle. That means AFC is equal to FA. But B is very near to P. So we can say FB is equal to F. Now calculate PC. PC is equal to, hence FB is equal to FP. So that means CF is equal to F. Now PC is equal to what will? That is the CF. It is CF plus F. Now PC is equal to CF. We can change it to FP. And here is FP. So PC is equal to 2FP. That means you can say PF is equal to PC upon 2. That is the R. You can see here. That is the R and this one is the small f. So you can write here small f is equal to capital R by 2. So that is the relationship between radius of curvature and the focal length. So always remember focal length is equal to radius of curvature upon 2. So that is the relationship between the focal length R, F and the radius of curvature R. So you can do this. Now come to the relation between object distance u, image distance v, and the focal length f for the mirror. So that is the formula. So it is, you can see here the formula is like this. That means 1 upon f is equal to 1 upon v plus 1 upon v. So that is the formula, and it is the relationship between the focal length, distance of object, and distance of image. So that is the formula you can do here. So the distance of an object from the pole is called the object distance, and it is u. Distance of image from the pole is called image distance, that is the v. The distance between the focal point f and the pole, that is called as focal length of the mirror. So this is the relation between the three quantities relative by the mirror formula. You can see here. Now come to the question. It is your example 1. How you can solve with the help of this formula. So an object is placed at a distance of 10 centimeter. So u is always, remember, it is negative. So minus 10 centimeter. From a convex mirror. Convex mirror focal length is positive. So f is given as 15 centimeter. Find the position, size, and orientation of the image. So you can see here. So find the v. The formula is 1 upon f is equal to 1 upon v plus 1 upon v. Now put the value. So 1 upon 15 is equal to 1 upon v minus 1 upon 10, because it is negative. So transfer to left hand side. So it will be 1 upon 15 plus 1 upon 10 is equal to 1 upon v. Taking the LCM, LCM is 30. So 15 2 ja, and here is 10 3 ja. So 1 upon v. So we can say this one is 1 upon v is equal to 5 upon 30. So 5 1 ja 5 and 5 6 ja 30. So 1 upon v is equal to 1 upon 6. So v is equal to 6 centimeters. So that one is your answer. Now how can find the size? So it is by the size magnification. Magnification m is equal to v upon u. So we can put here v is it is 6 and u is, as you know, that is the 10. So 2 5 ja 10 and 2 3 ja 6. So 3 by 5 times. So that is the answer. You can see that is the magnification. You can see here it is denoted by m. So magnification produced by spherical mirror is the proportional change in the size of the image or compared to the object. It's expressed as the ratio of height of the image to the height of the object. So you can say m is equal to I upon h. I is the length of the image and h is the length of the object. So you can say, but you can learn by this also. M is equal to v upon u is equal to I upon o, where I is the length of image and o is the length of object. So you can similarly you can learn by this also. Otherwise you can learn by the help of this formula. Now come to the lenses. Now use of spherical mirror. You can see uses of spherical mirror. First of uses of concave mirror. Usually concave mirror are used in torch, searchlights and headlights of vehicles to obtain a parallel beam of light. They are also employed as saving mirrors to obtain a large image of face. So dentists use this type of mirror to obtain magnified image of teeth. So large size concave mirrors are used for focus sunlight in solar power plants. So it is the uses of concave mirror. Now come to the convex mirror. What is the use of convex mirror? The mirror that you see on the side of a car, which the driver used to see the image of vehicles behind him, are convex mirror. So they are used as rear view mirror because they always from erect image, not inverted but The disadvantage is that image is smaller than the object. Since they are curved in a manner plugging outwards, they have a large field of view than the concave type. Some supermarkets have now installed large concave mirror at the turning so that two customers do not collide each other. So now come to the lenses. How can see what is the lenses? ये lenses हैं, इसमें दो आपके स्पेरिकल बॉल्स को मिला करके बनाते हैं. आपको ये दो स्पेरिकल बॉल दिखाई दे रहे हैं. इसका सेंटर ऑफ कर्वेचर C1 है, इसका सेंटर ऑफ कर्वेचर C2, and the radius of curvature, that is the R1, and here is R2. They are combined together and they form that type of lens, and that is the convex lens. It is called as convex lens. And the second lens, that is the concave lens, you can see it is looking like this. It is concave lens. So that is the two types you can see here. But now come to this one. It is the convex lens, and it is concave lens. You can see here. Parallel जो भी beam of lights आती हैं, after reflection it will be just reaching at one point, and that is the focus. ये कन्वर्जेंट कर देती है सभी लाइनों, सभी रेज को एक जगह कन्वर्जेंट कर देती है. इसमें डाइवर्जेंट आता है, मतलब सबको फैला देती है. देखो रेज जो है पैरेलल टू प्रिंसिपल एक्सिस चल रही है, ये आफ्टर रिफ्लेक्शन ये फैल गई है यहाँ पे, एंड इट सीम्स टू बी कमिंग फ्रॉम द फोकस F1. नाउ कम टू द sign convention for spherical mirror. It is similar that the mirror. Now come to the, it is the convex. It is not mirror, it is lens. You can say it is lens, not mirror. You can write here lens. It is convex lens. Now there is the focus to F2, C2, and F1 and C1. Right. So in front of the lens, that is the negative distance, and the downward the axis, so that is the negative, upward the axis, that is the positive, always remember, and behind the lens, that is the positive direction. Also you can see in the concave lens, what is the direction of the in front of the lens, that is the negative direction, you can see here, and the right hand side behind the lens, that is the positive direction, and the downward the axis, it is negative, and the upward of the axis, that is the positive direction. So this is the sign convention for spherical lenses. Now come to the rules for image formation of the lenses. So how can form the first rule? What will be happen on ray light traveling along the principal axis as it gets refracted by the lens? ये पता लगाना है कि ये जो रेज आ रही है वो आफ्टर रिफ्लेक्शन कहाँ जाएगी. सपोज आपका ये पैरेलल टू प्रिंसिपल एक्सिस आ रही है, तो ये हमेशा फोकस F2 से होकर के जाती है. दैट इज द लॉ. एंड सपोज ये यहाँ पर अगर पैरेलल टू है ये, तो इट सीम्स टू बी कमिंग फ्रॉम फोकस F. तो इस तरह से आएगा ये. यहाँ पर आपको एक और दिखाई दे रही है इमेज. ये ऑप्टिकल सेंटर से कोई भी रेज जाएगी तो विदाउट बेंडिंग ये बिल्कुल क्लियर पार्ट निकल जाएगी. So you can see that rule is in both the lens. Here is concave. It is not mirror, it is lens. Always remember it is lens, not mirror, it is lens. So you can correct in your book also. So that is the law. Now come to the second. So that is the parallel to principal axis, and after reflection it will be passes from the focus. So you can see here it is coming from parallel and it is passes through focus. That is the focus, and it is principal axis. You can write here principal axis. Now you can say in concave, just you can write it is not a mirror. You can write it is lens, and here is also it is mirror. It is lens. So you can write here. Now it is the seems to be coming from the focus. That is the focus. So the path of the ray is looking like. Now second, so what will be happen when ray of light traveling from the focus? So it is coming from focus. You can see here it is the focus point, and after reflection it will be parallel to the principal axis. ये principal axis के parallel होगी. और जो यहाँ पे यहाँ seems to be है, so it is coming from focus, but after reflection it will be also parallel to the principal axis. So always remember, it is not a mirror, it is lens. Also here is not mirror, it is lens. Now come to the next, and that is the when object is at infinity. जब object हमारा infinity पर है तो इसकी image focus पे form होती है, and that is the real image, real inverted, highly diminished, and the behind the lens. It can be obtained on the screen. And here behind the object 2f1 के बाद रखा जा रहा है, यानी सेंटर ऑफ कर्वेचर के दूर रखा गया. ये ऑब्जेक्ट रखा हुआ दिखाई दे रहा है आपको, इसकी इमेज यहाँ फॉर्म हो रही है. लॉ लगाने हैं, पहले तो ये प्रिंसिपल एक्सिस के पैरेलल रेस जा रही है, और आफ्टर रिएक्शन इट विल बी पासिस थ्रू द फोकस. यू कैन सी हियर, and when it is passes from center, optical center, it will be without deviation can pass, and they intersect this point A dash. So the A dash B dash is the image, and the image is formed as between focus f2 and 2f. So the image from real inverted smaller than the object, and it can be obtained on the screen. It can be obtained on the screen. Now come to the next. When object is placed on 2f1, so it is the 2f1. So you can say that is the AB is the object, and here is the A dash B dash is the image. So you can see here. So there is two laws. First, parallel to the rays, parallel to the principal axis, and after reflection, it will passes through the focus. And the second is the when it is passes from center, optical center. So it will without deviation it can move. So where they intersect to each other, that form the image. It is also real, inverted, and same size of object. Here you can say it is the larger, bigger. रियल है यहाँ पर भी, इसमें भी रियल इमेज बनेगी, और you can write real image, inverted, and large size. So you can see here at the focus, you can say on the object, that is the f1. So image is formed at infinite and the highly magnified. So real image, real, inverted, highly magnified. Here it is the imaginary image. So you can see here it is the virtual image. You can say in this virtual image, and erect, it cannot be obtained on the screen. It cannot be obtained on the screen. So in all this possibility, there is the possibility they can obtain on the screen. इन सभी पे जो है जितने भी यहाँ दिखाई दे रहे, ये हो गया, ये हो गया, ये हो गया, इन सब में इमेज जो है स्क्रीन पर ले सकते हैं, बट इन दिस केस देयर इज नॉट पॉसिबिलिटी टू टेक द इमेज ऑन द स्क्रीन. Now let us see the image formation by the concave lens. It is the concave lens when object is at infinite. So infinite, it is the from infinite. So the image is formed here, that at focus, and it is the virtual image, virtual, direct, and it cannot be obtained on the screen. It cannot be obtained on the screen. Here is also a virtual image and the small size, small, virtual, or same side of object, same side of object. रे डायग्राम आप लोग अपने आप बनाएंगे. इट इज वेरी सिंपल. बस इसमें दो ही लॉ लगाने, एक पैरेलल टू द प्रिंसिपल एक्सिस एंड आफ्टर रिफ्लेक्शन इट विल बी पासेस थ्रू द फोकस और सीम्स टू बी फोकस. एंड सेकंड जो है ऑप्टिकल सेंटर से पास करेंगे और सीधे चली जाएगी. नाउ कम टू द रिलेशन बिटवीन the object distance u, image distance v, and the focal length of f. The formula is 1 upon f. It is 1 upon v minus 1 upon u is equal to 1 upon f. You can see further 1 upon f is equal to 1 upon v minus 1 upon. ध्यान रखना मिरर में जो है ये बीच में प्लस होता है, लेकिन लेंस के लिए बीच में ये माइनस होता है. Okay, magnification, you can see magnification. It is the same formula. M is equal to h dash upon h or v upon u. So, but you can learn like this: M is equal to v upon u is equal to I upon. So, it is very simple to learn. I is the length of the image, O is the length of the object, V distance of image, and U distance of object. M is the magnification. How many times can form the image? Now, come to the next one. Power of a lens. Power of a lens, that is the 1 upon f focal length in meters. So you can write here in meter. And the unit is diopter. Their unit is diopter, so you can, it is represented by capital T. So you can say it is the power is equal to 1 upon f in meter. So unit is diopter. So you can write diopter. And it is represented by D. For concave lens, it is negative, and for convex lens it is positive. Now come to the question, how can do this, how can apply the formula in this. A convex lens has focal length 10 cm. Convex lens, that is the f, it is plus 10 cm. An object is placed 2 cm long, so that is the O is equal to 2 cm. It's kept at a distance of 15 cm, so that is the U is equal to minus 15 cm. Always remember U is always negative. So now we can find the V. So formula is 1 upon F is equal to 1 upon V minus 1 upon U. Now it is 1 upon 10 is equal to 1 upon V. Minus plus, so 1 upon 15. Now transfer to left hand side, so 1 upon 10 minus 1 upon 15 is equal to 1 upon 15. Taking their LCM, LCM is 30, so 10 3 ja 30 and 15 2 ja. So we get 1 upon V. So we can write here 1 upon V is equal to, here is 3 minus 2, that is the 1. So 1 upon 30. So we can say V is equal to 30 cent. So that is your answer. M is equal to V upon U is equal to I upon O. Now put the value. V is given as 30. As you know, U is equal to 15. So you can put here 15. I we want to find, and O is given as 2 centimeter. So you can write here 2 centimeter. Now we can find the I. So I will be equal to, you can see here, I will be equal to, that is the 30 into 2 upon 15. So 15 1 ja 15 and 15 2 ja 30. So I will be equal to 2 into 2, that is 4 centimeters. So that one is your answer. It is a photographic camera. You can see here. This one is the photographic camera. You can see in this there is the film. One film is here, which is loaded. That one is the film, and it is the apparatus aperture rings. So that one is the shutter controller. तो शटर की सहायता से आगे पीछे कर सकते हैं और यहाँ पर ये कॉन्वेक्स लेंस है ये दैट वन लेंस इज कॉन्वेक्स दिस वन एंड दैट्स ओनली द शटर is the shutter and diaphragm it is the diaphragm and the focusing key it is the focusing key this one इसको आगे पीछे मूव करके हम फोकस कर लेते हैं तो हमारी इमेज पे है कुछ ऐसे बनते हैं इनफाइनाइट पे कोई इमेज रखी हुई है ऑब्जेक्ट और ये फोकल पे हमारा बना के देता है फोकस ये इनफाइनाइट पे करीब होता है with respect to the focal length of the convex lens. It is your convex lens. Now come to the construction and the working. So camera is made up of a metal or plastic and it is inner portion is painted black. It is light insulating. The front side of box is fitted with a convex lens whose focus can be adjusted. This lens is of short focal length and is called objective lens. The image formed by this lens is free from all the defects. There is a circular screen behind the lens which has a small hole at the center and is called diaphragm. Using the diaphragm, amount of light entering into the camera can be controlled and image of an object is formed on the photographic film. Using the shutter, light is allowed to fall on the photographic film for a definite time. The object to be photographed is in front of the lens at a distance more than twice its focal length in this condition, real, inverted and the diminished image of object is formed on the film. So it is the description and working of the camera. Now come to the telescope or microscope. So it is a microscope. A convex lens is called microscope and it is used as reading lens or imaging magnifying lens. A convex lens with very small focal length is called a simple microscope. If a combination of lens is used, then the assembly is called a compound microscope. First of all, object is placed in front of the object lens. It is given as object lens. It is object lens and it is the eyepiece. So you can see here. And the image is formed with the lens of this L1. So that one the A dash B dash, and that image is working object for this lens. So it forms a A double dash B double dash image. So that is a highly enlarged. The image is formed. Fifth one, the focal length of convex. It is not a concave, it is the convex length. It is 40 centimeter for an object placed 40 centimeter away from the lens. The image will be formed at. So image will be formed at infinity. So that is the infinite. Now sixth one, the lens is kept on the book and then rise by 3 centimeter. Then the text now appear erect and large. The focal length of the lens is more than 3 centimeters. So you can learn this by heart. Now come to the next one, that is the fill in the blanks. So fill in the blanks. The image formed by the convex mirror is always diminished and virtual image. Now second one is to obtain real image size, same size of the object from the convex lens. The object must be placed at center of curvature. You can write center of curvature. Third, the power of lens is plus 5D. The focal length of the lens will be 20 centimeter. Now fourth one is the focal length of convex lens is 25 centimeter. Then the power of lens will be plus the 4D. So that means you can fill all these blanks. Now come to this one. Write down the relation between the radius of curvature and focal length by spherical mirror. So that is the F is equal to R by. You can write the focal length, that is the R, and the radius of curvature. R is the radius of curvature and F is the focal length. So you can say F is equal to R by 4. It is the relationship between radius of curvature and focal length. Now come to the next fourth question. In what types of mirror is the linear magnification less than 1, equal 1 and greater than 1? So you can apply in the plane mirror, linear magnification is always 1. In convex mirror, linear magnification is always less than 1. And in concave mirror, the linear magnification may be less than or equal or greater than 1. The rear view mirror used in vehicle are convex mirror. Why? So you can write the answer. Convex mirror is used as rear view mirror in the vehicle because it always forms virtual, erect and the diminished image of the object. Their field of view is larger as they are bugged outwards. Therefore, the driver can see the larger area behind him, which helps in safe driving. So that is the reason why it is used. Now come to the sixth question. If image is to be obtained on a screen, what type of mirror should be used? So you can write concave mirror is the suitable to have image of object on the screen. This is because concave mirror forms real and inverted image of the object. So real can be obtained on the screen. By drawing ray diagram for parallel incident beam of light express what type of mirrors are converging and what type of diverging. So as you know, concave mirror is converging and the convex mirror is diverging. You can see in your figure. This one is the figure. So you can write chain of parallel incident rays in the spherical mirror. When the incident rays parallel to principal axis pass on the spherical mirror, then the reflected rays meet at a point and appear to meet at a point on principal axis, that is in concave mirror. Therefore, concave mirror is a converging mirror and the convex mirror is diverging mirror. In case of concave mirror, after reflection, the rays of light converge, meet at a point, and in convex mirror, the rays of light diverge. That is the separate. It is given as figure is given also. Now come to the eighth question. Define the following terms. So mirror first has center of curvature, second radius of curvature, third fourth and the aperture. So answer is, you can say center of curvature. The center of the sphere of which the mirror is a part of is called the center of curvature of spherical mirror. Now come to the radius of curvature. It is the distance between pole and the center of curvature of spherical mirror. Now pole, the center of reflecting surface of spherical mirror is known as its pole. So that one is your answer. Question number 9. Write a note on the converging and diverging nature of lenses. So first, it means that the convex lens bends the rays towards principal axis due to which rays converge. Therefore, concave lens is of converging nature. On the contrary, concave lens bends the rays away from the principal axis due to which rays appear to diverge. So therefore, nature of concave lens is divergent. So you can see in the figure, you can write it is the convex lens and it is the concave. So you have to write and draw this diagram. Now come to the 10th question. What is the power of a lens? Write its unit. So power of lens is the reciprocal of its focal length. It is denoted by P and therefore power of a lens having focal length F will be P is equal to 1 upon F in meter. You can see here F in meter. So unit of power of lens is dipole. Its focal length is in meter. ध्यान रखना इसकी focal length मीटर में होनी चाहिए. Dipole मतलब diopter है ये, not dipole. So diopter is the unit of the power lens power. Now come to the next one. Write down the sign convention used in lens. ये sign convention मैंने lens का पहले ही बता दिया था. In front of the lens, this lens is the convex lens. You can see here, and that one is the concave lens. So this lens, so the in front of the lens is always remember it is negative, and behind the lens that is the positive, and the downwards of the principal axis that is the negative, and the upward that is the positive. So you can see in this figure, and similarly the same, it is the concave lens. So you can say here डाउनवर्ड डिस्टेंस अगर लेंगे तो ये नेगेटिव हो जाएगा, अपवर्ड डिस्टेंस लेंगे तो पॉजिटिव रहेगा, और लेफ्ट हैंड साइड में चलेंगे तो नेगेटिव रहेगा, राइट हैंड साइड में चलेंगे तो पॉजिटिव रहेगा डिस्टेंस के. चलिए देखते हैं. क्वेश्चन है व्हाट विल हैपन पावर ऑफ कॉन्केव लेंस इज ऑफ फोकल लेंथ 50 सेंटीमीटर. ये है क्या है कॉन्वेक्स लेंस. सो एफ इज गिवन एज 50 सेंटीमीटर. व्हाट if the lens is concave? First of all, we can change it into meter. So F is equal to 0.50 meter. Now power P is equal to 1 upon F in meter. So put the value 1 upon F, that is the 0.50, remove the decimal and put here double zero, 0 will be cancelled and 5 1 the 5, 5 to the 10. So we can say plus 2 diopter. That will be your answer. Now come to the next. 13 question. An object is placed at a distance of 15 centimeters from the pole of the concave mirror. Concave mirror, so U is equal to minus 15 centimeters. Focal length is 10 centimeters, so F is equal to 10 centimeters. But length is concave, so it will be negative. What is the size, position and nature of magnification of the lens? So we can find the V. Now formula 1 upon F, if it is mirror, so mirror formula we can use 1 upon F is equal to 1 upon V plus 1 upon V. Put the value. So it is the minus 1 upon 10 is equal to 1 upon V and minus 1 upon 15. Now transfer to 15 that the right hand side, so it becomes positive. So 1 upon 15 minus 1 upon 10 will be equal to 1 upon V. Now taking the LCM is 30. So 15 2 ja and 10 3 ja. So 1 upon V, that means it is minus 1 upon 30 is equal to 1 upon V. So V will be equal to minus 30 centimeters. It is your first answer. But the magnification, that is the V upon U. So V is given as 30 and U is equal to 15. So 15 1 ja 15 and 15 2 ja 30. So through 2 times, it will be 2 times. So that is the magnification. So it is given as minus 2 times. Now come to the next question. The radius of curvature of convex mirror is 30 centimeters. So you can write here capital R is equal to 30 centimeters. So F is equal to R by 2. So that means 30 divided by 2. So it becomes 15. So that is the 15 centimeter and it is 40. An object is of height is 5 centimeters. So that is the object, it is of 5 centimeters. Kept at a distance of 10 centimeters, that means U is equal to minus 10 centimeters. From the pole, find the nature and size of the magnification. So you can write here 1 upon F is equal to 1 upon V plus 1 upon V. Put the value, so F is 15, so you can write 1 upon 15, 1 upon V. We want to find V and it is minus 1 upon 10. So change the left hand side. So it becomes positive. So 1 upon 10 plus 1 upon 15 is equal to 1 upon 10. Now taking the LCM, that is the 30. So 30 10 3 ja and here 15 2 ja. So 1 upon V. So that is the 5 upon 30 will be equal to 1 upon V. So 5 1 ja 5 and 5 6 ja 30. So 1 upon V is equal to 1 upon 6. So V is equal to 6 centimeters. Now come to the magnification. It is the first answer. Magnification M is equal to V upon U is equal to I upon 2. Put the value. V is given as 6 and U is given as U is given as 10 and I we want to find and O is given as, there is 5 centimeter. You can see here it is the 5 centimeter. Now I will be equal to 6 upon 10 into 5. So 5 1 ja 5, 5 2 ja and 2 1 ja 2, 2 3 ja 3. So I is equal to 3 centimeter. So that will be your answer. The focal length of concave mirror is 10 centimeters. So F is equal to minus 10 centimeters. Concave, so that why it is negative. To obtain the image 5 times, so that is the F is equal to 5 times. Bigger than the object, where should be the object placed so that image first one is real and then second is virtual. So first one, so real. So M is equal to V upon U. Put the value. So it is the 5 and V is equal to U. So we can say V is U is equal to or V is equal to 5U. Okay, for real image, no, we can apply the formula. As you know, U is equal to minus u, and v is equal to, for real, it is the mirror, real is minus 5u. So put the formula 1 upon f is equal to 1 upon v plus 1 upon u. So the formula 1 upon f is minus 1 upon 10. V is given 1 upon minus 5 u, and minus u is also u. Now change their all the sides. So 1 upon 10 is equal to 1 upon 5u and plus 1 upon. Taking their LCM, LCM is 5u, and here is 1 plus, and here is 5. So that is the 1 upon 10. So 1 upon 10 will be equal to 6 upon 5u. So u will be equal to how much? It is the 1 upon 10 into 5 upon 6. So 5 1 ja 5, 5 2 ja 10. So u will be equal to, it is 1 upon 12. So that one is your answer. It is 1 upon, not 1 upon. We can do the further. U will be equal to how much? So 5 multiplied to here. So 1 upon 10. U is here and 6 into 10. So that one is 6 into 10 upon 5. So 5 1 ja 5 and 5 2 ja 10. So u will be 6 to the 12. So that one is your answer. Now come to the second for virtual. Second for virtual. For virtual, so you can say u is equal to minus u and v is equal to plus 5u. So you can apply the formula 1 upon f is equal to 1 upon v plus 1 upon u. So 1 upon f, that is the minus 1 upon 10, will be equal to 1 upon v, that is the 5u, and plus 1 upon u, and it is in negative sign. It is minus 1 upon 10 is equal to, taking the LCM, it is 5u. Here is 1 minus 5 1 ja 5, so you can write 5. So what will be happen? You can go on next page, or you can say here. So minus 1 upon 10 is equal to minus 4 upon 5. So u will be equal to minus, cancel to minus. So u will be equal to 10 into 4 divided by 5. 5 1 ja 5, 5 2 ja 10. So u will be equal to 8 centimeter. So that one is your next answer. Now come to the 16. The radius of curvature of convex mirror is 30 centimeter. So that means R is given as 30 centimeter. What will be the size, position and nature of the image when object is placed 12 centimeter from the pole? So u is equal to minus 12 centimeter. Do the same calculation for the concave mirrors. Okay, it is the convex. Convex f is equal to r by 2. So that is the 15. It is the 30 divided by 2. 2 1 ja 2 and 2 15 ja 30. So f will be equal to 15 centimeter. The formula is 1 upon f is equal to 1 upon v plus 1 upon v. Put the value 1 upon f, that is the f is how much? 15. So 1 upon 15 is equal to 1 upon v. V we don't know, so we can write v as a v, and u is minus 12, so you can write 1 upon 12 with minus sign. Now we can say 1 upon v is equal to 1 upon 15 plus 1 upon 12. Taking their LCM, that is the 60, so 15 4 ja, and here is 12 5 ja. So 1 upon v. So 1 upon v is equal to 60, and here 5 6 9. So 9 So 3 3 ja 9 and 3 2 ja 6. So we can say V is equal to 20 upon 3. That the 6.67 centimeter. It is your first answer. Now that one is the convex mirror. Suppose the answer second is when it is a concave mirror. You can write for concave mirror. For concave mirror, that is the F is equal to minus 15 centimeter. So apply the formula 1 upon F is equal to 1 upon V plus 1 upon U. Put the value 1 upon 15 minus 1 upon 15 and V we want to find, and here is minus 1 upon 12. Now transfer this side. So 1 upon V is equal to 1 upon 12 minus 1 upon 15. Taking the LCM, that is the 60. So 12 5 ja and minus 15 4 ja. So that is the 1 upon V. So 1 upon V is equal to 1 upon 60. So V will be equal to 60 centimeter, and that is the second answer. Now come to the 17th question. The image of an object kept at 30 centimeters from the pole of a convex mirror forms at 10 centimeter. What is the focus length of the mirror? Once again, the image of an object kept at 30 centimeter form. So that is the U is equal to minus 30 centimeter, and the image is formed at 10 centimeter. So we can say V is equal to 10 centimeter. Now formula is 1 upon F is equal to 1 upon V plus 1 upon U. It is for mirror. Now put the value, it is 1 upon F is equal to 1 upon V, that is the 1 upon 10, and minus 1 upon U, that is the minus 1 upon 30. Taking the LCM, 1 upon F is equal to LCM is 30, so 10 theta and 10 1 ja. So 1 upon F is equal to 2 upon 30, so 2 1 ja 2, 2 15 ja. So 1 upon F is equal to 1 upon 15, so F will be equal to 15 centimeter, and that one is your answer. 18th question, the focal length of the concave mirror. It is concave mirror, so F is equal to minus 12 centimeter. If an object is placed at focus means, so U is equal to minus 12 centimeter. Where will the image is formed? So we want to find the image, that is the V. So 1 upon F is equal to 1 upon V minus 1 upon U. Put the value, so minus 1 upon 12 is equal to V is 1 upon V, and here is minus, it is the mirror, so formula is positive. So that is the minus 1 upon 12. Now 1 upon V is equal to minus 1 upon 12 plus 1 upon 12. So that will be cancelled out. So 1 upon V is equal to 0. So V is equal to 1 upon 0. So that is the infinite. So at infinite. So that one is your answer. Now come to the 19th question. The focal length of a convex lens is 15 centimeter. So F is given as 15 centimeter. It is the convex length, so it is positive. Where should be the object placed and obtained to image 3 times? So M is given as 3 times. So M will be equal to V upon U. It is V. M is given as 3 and V upon U. So V is equal to 3U. The lens is convex, so we can apply the formula. As you know, U is always minus U, and here is the lens is convex lens. So image is erect and the virtual image, so V is 3U. So formula is 1 upon F is equal to 1 upon V plus 1 upon V. Put the value. 1 upon f, that is the 1 upon 15 is equal to 1 upon v. V is given as 3u. So you can put here 3u and minus 1 upon u. Taking the LCM is 3u and here is 1 minus 3. So here is 15. So 1 upon 15 is equal to minus 2 upon 3 u. Now u is equal to minus 2 into 15 upon 3. 3 1 the 3, 3 5 the 10. So u will be equal to minus 2 into 5. So that is the minus 10 centimeters. So that one is your answer. In case of lens, it is negative. You have to see that is the negative point. So you can write here negative. So it will be negative, that it becomes positive, and it is also positive, so it becomes 4. And 4 into 5, that is the 20. You can write here 4 into 5, that is 20 centimeters. So that is the answer. You can write correct this one. Now come to the question number 20. The focal length of concave lens is 30 centimeters. It is lens. So f is equal to 30 centimeters. What will be the position and size of the image if a 30 centimeter long object is placed at focus? It is placed at focus, 30 centimeter long. So O is given as 30 centimeter and focus, so U will be equal to minus 30 centimeter. So your formula is 1 upon, it is the concave not convex, so the focal length is negative. So 1 upon F will be equal to 1 upon V minus 1 upon U. It is length, so you can say it is negative. So 1 upon F, that is the minus 1 upon 30, and the 1 upon V minus 1 upon U, that is the minus plus, so 1 upon 30. Now minus 1 upon 30 and here is minus 1 upon 30 is equal to 1 upon V. So we can say here it is minus 2 upon 30 is equal to 1 upon V. So it will be 15. So we can say V is equal to minus 15 centimeters. Now as you know, M is equal to V upon U is equal to I upon 4. V is given as 15 and U is, that is the 30, and I we want to find, and O is 30 centimeters. Now 30 cancel out, so I will be equal to 15 centimeters. That is the length of the image, and this is your answer. Now come to the next one, that is the 21. For an object kept at 30 centimeters from a concave lens. So lens is concave, so U will be equal to minus 30 centimeters. It is clear that it is minus 30 centimeters. The magnification of achieved is 2 by 3. So M is given as 2 by 3. What is the focal length of the lens? So that is the concave lens. So F will be find out. So now M will be equal to V upon U. So M is 2 by 3. V is given as, we want to know, U is equal to 30. So now V is equal to 2 by 3 into 30. So 10 times. So V is equal to 20 centimeters. But concave lens is always forming virtual image. Virtual image. Always remember virtual image. For virtual image, so V is always negative. That is the 20 centimeters in minus. Now we can apply the formula Vf1 upon F is equal to 1 upon V minus 1 upon U. It is for the length. Now V is given as minus 20, so we can say 1 upon minus 20 and minus plus, so we can say it is 30. Now taking the LCM, that is the 60 minus 20 3 ja, and it is 32 ja. So it becomes minus 1 upon 60. So 1 upon f. So you can say f is equal to minus 60 centimeters. So that will be your answer. Now come to the 22 question. For convex lens, focal length is 50 centimeter. Is it positive? So it is the plus f. F is equal to plus 50 centimeter. What is the position of image of the object is placed at a distance of first at 25 centimeters. So first we have to write u is equal to minus 25 centimeter. Now come to the formula. 1 upon f will be equal to 1 upon v minus 1 upon v. It is for length. Now f is 50, so you can write 1 upon 50 v. We want to find v and it is the negative, so it becomes positive. So 1 upon 25. So 1 upon 50 minus 1 upon 25 is equal to 1 upon v. Taking the LCM, it is 50 and here is 1 and minus 2 is equal to 1 upon v. So minus 1 upon 50 is equal to 1 upon v. That means v is equal to minus 50 centimeter. It is your first answer. Now second. So that one is the first part, and the second part, if u is given as 75 centimeter, u is equal to minus 75 centimeter. F is always this. Now put the value. So 1 upon f is equal to 1 upon v minus 1 upon. Put the value. F is 1 upon 50 is equal to 1 upon v and minus plus 1 upon 75. Now 1 upon 50 minus 1 upon 75 is equal to 1 upon. Taking the LCM is 150. So 50 3 and 75 2. So 1 upon v. So that means 1 upon 150 is equal to 1 upon v. So we can say v is equal to 150 centimeters. So that is your second answer. Now come to the 23rd. What is the focal length of a lens whose power is given as 1.5? So power is given as plus 1.5d. So the formula is P is equal to 1 upon f in meter. Power is given as plus 1.5 and here is 1 upon f in meter. So f will be equal to 1 upon 1.5 मीटर यहाँ आ जाएगा. Now इसको सेंटीमीटर में चेंज करना है तो 1.5 into 100 centimeter. So point remove with this, so we can use 10. So 5 3 here and 5 2. So f will be equal to 200 upon 3. So that is the 66.7 centimeter. So that one is your answer. Now come to the 24th question. What is the power of a concave lens of focal length 20 centimeter? So f is given as, it is a concave lens, so it is negative 20 centimeter. Change into meter, it is minus 0.20 meter. So power is equal to 1 upon f in meter. Now put the value. So 1 upon minus 0.20. Now remove the point. Here is the 100. So 0 will be cancelled out. So 5 1 the 5, next 2 1 the 2, 2 5 the 10. So that is minus 5d. G is the unit diopter. So that one is your answer. ये एक्सरसाइज बच्चों आपकी समाप्त हो रही है. ये लेसन समाप्त हो रहा है. नीचे एक लाल रंग का बटन दिखाई दे रहा है. इसको दबा करके सब्सक्राइब कर लेंगे और ज्यादा से ज्यादा बच्चों को शेयर करेंगे जिससे ज्यादा बच्चों का फायदा हो सके. इतना करने पर कम से कम एक लाइक तो बनता है. तो मेरे वीडियो को लाइक भी करेंगे. इसी के साथ मैं आर एस प्रसाद सर आज का वीडियो यहीं समाप्त करता हूँ. थैंक यू. हैव अ नाइस डे.